we're going to work on section 6.5, which is solving absolute value equations. This is kind of where the rubber hits the road, you might say. You need to pay good attention today to these notes. We are not working on inequalities today. We will the next time we get together. Today we are working on equations, but they're absolute value equations, which more than likely most of you have not worked with before. Absolute value equations will have two answers most of the time. There's one exception to that rule, and we'll talk about that one as we go through here. What does an absolute value equation look like? Well, something as simple as this. The absolute value of x equals 9. You all know that if I came up to you and said, hey, what's the absolute value of 13? What would you tell me the absolute value of 13 is? Jake? 13. How about the absolute value of a negative 13? What would you tell me? Taylor?
13.
Also 13. So the absolute value of a number is just how far away from 0 it is. And what do you know about that absolute value answer? What is it always? Jordan? It's always positive. That's right. But notice that the two numbers that I gave, the absolute value of 13 and the absolute value of negative 13, what's inside the absolute value bars isn't always positive. And so that's where this kind of an equation comes into play here, because we have to find out what can x be so that the absolute value of it equals a positive 9. Do you got any ideas on what x could be so that its absolute value is always 9, Jack?
Negative 9.
Could be negative 9. Could it be anything else, Ben?
Positive 9.
Could be positive 9. Now what we're going to do here is what is inside here is written two ways. You either write x equals the positive 9 or x equals, and we have to have a negative in front of it. Because you guys all know that if I take the absolute value of any number, it has to become the positive of that number. But while it's inside the absolute value bars, it could be positive or negative. Please notice my two equations. Do I have absolute value bars around the x's in my two equations? No, you should not either. So make sure your notes don't have any absolute value bars right here. That would be incorrect to have down. Sometimes students do that, and I have to tell them that's wrong. Absolute value up here in our original equation, fabulous. That tells me, hey, I'm looking for two different numbers, more than likely in that equation. This is the most simple absolute value equation. I'll have one like this on the test. And people get it wrong because they only give me one answer. They'll say x has to equal 9. It's actually two answers. X equals a positive and a negative. You can write x equals a plus minus 9 like this. This would be appropriate. That shows me both a positive 9 and a negative 9. I will accept that kind of an answer if both of the numbers are the same number and that's just a difference of their sign. Okay. So on this particular problem, x could be equal to a positive or a negative 9. This could be our answer, or if you want to write them separately, that's fine with me. Okay. All right, let's see what we have next here. Let's make it a little more difficult. The absolute value of x plus 4, that's inside the parentheses, equals 3. Now, just like I did with that absolute value of x equals 9, I'm going to underline what's inside the parentheses, or inside the absolute value bars here. I'm going to draw two little arrows to say we have to set up two equations. Okay, if you want to have your red pen out and draw some little arrows for yourself, that's probably not a bad idea. So we're going to write down the x plus 4 either has to be equal to the positive 3, or what's inside those absolute value bars has to be equal to a negative 3. We have to get both scenarios, both possibilities. Well, now we have two equations. Just go ahead and solve them. What's going to be the solution to the first equation, please? First equation, what are we going to have as a solution to that? Colin?
X equals -1.
X equals -1. All righty. The second equation, what are we going to have as a solution to that, please? Jake?
X equals -7.
X equals -7. Let's put a box around those two answers. And let's check to make sure that they actually work. Put a -1 back into the original. -1 plus 4, class is? -1 plus 4. 3. Absolute value of 3? Cool. Let's put in a -7. -7 plus 4. Absolute value of a -3? +3. Please note these absolute value bars are an operation. Okay, they are not a grouping symbol. Absolute value bars. I'm going to stop this so I can write. Okay, the absolute value bars are an operation. They are not a grouping symbol. You do not distribute into absolute value bars. That's something that's later as we're starting to look at some problems. If you see something like 3 times the absolute value of x plus 4, sometimes students think, oh, I'm going to distribute the 3 inside. No, you can't do that. You have to divide by 3 to get rid of it. You got to get the absolute value bars all by themselves first. That is something that I want to caution you on right away. Absolute value bars are an operation. They are not a grouping symbol. So you cannot distribute here. Any questions there so far? Now let's try another problem here where we have solving the absolute value of x minus 3 is equal to 8. Set up what you think are the two equations that you would use to solve this, please. Two equations that you would use to solve this. I need a volunteer to give me two equations, please. Jack?
X minus 3 equals 8. X minus 3 equals -8.
All righty. X minus 3 equals 8, and x minus 3 equals -8. Those are the two equations that we should have. Now solve them. If you haven't solved them already, please solve them. Carissa, what's your solution on the first one?
I got x equals 11.
All right. And the second one, Angela, what's your solution?
X equals -1.
All righty. Let's put a box around those two solutions. Let's check to make sure Angela and Carissa are correct. 11 minus 3, class? 8. Absolute value of 8 is 8. -5. -5 minus 3, class? -8. Absolute value of -8? +8. You can check your answer. Okay, that would be a really good thing to do to make sure that it does work. These have been pretty easy ones. We need to make it a little tougher, don't we? Okay, do you have any questions so far? Rewrite the absolute value equation. Remember I commented the absolute value bars are not grouping symbols. Jot down this lovely equation, please. I'll pause a moment for you to do that. Okay. I wrote a little equation off to the side here because it's similar to what you have on your notes. 3a minus 7 equals 11. If I gave you this equation yesterday, what would you have done to start solving this equation? What would you have done, Emily?
Add 7.
Add 7, because you're trying to find out what a is, right? You're going to go backwards through your order of operations. Well, please think of this absolute value of 4x plus 2 as an entire grouping that has to stay together like that a. So the first thing we have to do, Jake,
Add 7.
is add 7. So whoops, I got to change it off of that. We have to add 7 to both sides, And I'm going to write down 3 times the absolute value of 4x plus 2 equals 11 plus 7, class? 18. All right. Then, just like you would have added 7 over here and had 3a equals 18, what would you do next on my little equation off to the side, Kyle? We would divide by 3, which is the exact same thing that you're going to do over here. You're going to divide by 3 because your goal is to get the absolute value bars all by themselves. You have to undo the operations so that you can get the absolute value bars all by themselves. Okay, so get the absolute value bars all by themselves. Now that you have them by themselves, we have to set up 2 equations. What are going to be the 2 equations that we are going to set up? Ellie?
4x plus 2 equals 6. And 4x plus 2 equals 6.
Exactly. What is inside those absolute value bars gets set equal to both a positive and a negative 6. I'm going to pause a moment. I want you guys to finish up solving that. I need answers for these 2. We are subtracting 2 on both of them, but let's do them each individually. And so we've got our 4x equals 6. Mr. Shrinian, what do we got? Not 4x equals 6. 4x equal what, Nick?
This is, got 4.
4. Okay, and therefore x is equal to 1. All righty. So minus 2 on each side here. I've got 4x equals hopefully a negative 8. Bill, what'd you come up with? X equals negative 2. All right. Questions there? Starting to make a little sense of what you're supposed to be doing? Having to have 2 equations? Then we'll do this one, and I'll have some people come up to the board on this one. We have up here getting the absolute value bars all by itself so that we have the absolute value of 2x minus 7 equals 3. Lucy, since you just joined us, we're treating this like a normal equation where, this is kind of like one whole variable, a whole grouping. So we're adding 5 to both sides and then dividing by 3. Excuse me. Thank you. So that the 2x minus 7 that's in the absolute value bars is all by itself. And then what we are doing with that is we are setting what's inside those absolute value bars up into 2 equations. Notice the positive 3 and the negative 3. Because we know what's inside absolute value bars can be positive or negative. But once it comes out, it's a positive number, which is what this number is here. So then they solved each of those equations. Jake solved here on the smartboard for us. We got 5 and 2. Everybody who did it up on the whiteboard got 5 and 2 as well. Put a box around both answers so that I can find them easily when you do your homework, when you do your quiz and your test. That way I don't have to search for them. Okay. So kind of a real quick glance at that. We'll do some more, Lucy, so that you catch up. Okay. Any questions from those of you who have been here all the time already? All right. Let's take a look at this one. It says absolute value of r minus 7 equals 9. I'd like you to do this problem, please. What we have up here for answers are 16 and negative 2. Remember, we don't put any absolute value bars around the information as we are working with it here. These areas right here, no absolute value bars get around them. Think of it as what's coming out from inside there. It's like your microscope that suddenly you're coming in closer and just looking at what's inside the absolute value bars. Absolute value bars we don't write down when we're setting up our 2 equations. Any questions there? See what's going on a little bit, Lucy? Okay. Let's make it, just a second. I like this one better. Let's go to this one. 4 times the quantity, t plus 9. And then that minus 5 equals 19. This is a good one for you to do. We have the absolute value of t plus 9 is equal to 6 once we get rid of that negative 5 and that 4 there. And we come up with t is equal to a negative 3 and a negative 15. Those 2 answers are correct. And the work is correct for everybody on both the smartboard and the whiteboard. Any questions there at this point? at all? All right. What if there is no solution? Now, let me tell you what kind of a problem looks like no solution. Would you jot down 3 times the quantity, or excuse me, 3 times the absolute value of 2x minus 8 plus 3 on the outside equals 2? Let's jot down that equation. As you would start solving this problem, what would be the first thing that you would do to both sides of the problem, please? Ellie?
Subtract 3.
All right, we're going to subtract 3. And when we do that, we get 3 times the absolute value of 2x minus 8 equals, what's on the other side? -1. All right, are the absolute value bars by themselves yet? No. So we have to continue until the absolute value bars are by themselves. So what do we do next in order to solve this, Jordan? Okay, let's divide by 3. When we do that, that's the absolute value of 2x minus 8 is equal to, what do we have on the right-hand side? Jordan? -1/3. We get a fraction. Please don't give me a decimal, repeating decimal there. -1/3. Now, I have a problem. Absolute value of something equals a negative? Can that be? Oh, no way. So at this point, I would stop. Bells and whistles should be going off in my head. Good timing, wasn't it? And I would write no solution, because I can't have the absolute value of something be equal to a negative. There is no number that will ever work in that equation and make it a true statement. So that's the only time there aren't 2 answers. Otherwise, you will always get 2 answers for your absolute value equations. So if when you are simplifying and you get down to the absolute value of whatever's inside there equals a negative, then you will write that there is no solution. It's because that number is negative that there is no solution. Questions there? Pretty easy concept, right? Absolute value of something is a negative. Hold it. Not true. Okay. You do this one, please. We have the absolute value of 3x plus 5 equals -8. That's where everybody stops. No solution at that point. How? Absolute value. If I say the absolute value of, let's say, of a -8, can that be equal to a -8? Oh, okay. You understand? God can't have the absolute value of something be equal to a negative. It's like, I can't even comprehend that, can we? Yeah, that's like trying to divide by 0. Nobody knows how, right? Okay, any questions there? All right. I'm going to talk about this story problem because I'm going to talk about absolute deviation a little bit. I want you to realize that there's absolute deviation out there in this world, in case somebody sometimes says something to you about it. Absolute deviation is like how much error something can have. Is anybody perfect? Any of you perfect? Oh, Nick says, yeah, I kind of am. So is Jake. Okay. How about if you created something, if you drew a line, that I said draw a line that's 6 inches long, would it be exactly 6 inches long? It might be 6.01 inches long. But will it be exactly 6 inches long? If I told you to use a ruler, only if you stopped at just the precise point. I tell you to sing for 3 minutes, not a second longer. Could any of you do that? If I ask you to sit on your chair without rocking on the back of it every day for the rest of your life, could you do that? No, I don't think that's a tough one. That's worse than trying to sing for 3 minutes. Okay. here's the deal. We know that there is a margin of error on things. It can be off a little bit. You know, unless you are a physicist and you're dealing with very minute measurements, more than likely things are off just a smidge. Well, we have an ad. The people want to have a 2-minute radio ad, but it can be off by 0.05 of a minute. That's how long they'll let it run. Long or can be short. Have you ever listened to the radio and when an ad gets done, there's dead airspace? Have you ever listened to an ad where all of a sudden the ad's finished and it's like nobody's saying anything on the radio? It's called dead airspace, and that's because they didn't make sure that their ad ran long enough for what was going on there. So it says find the minimum and the maximum acceptable times that the radio ad can run. Well, there's a way that you have to set this up. You're going to have X minus the time it's supposed to be. The time it's supposed to be. And then we put absolute value bars around that, equals whatever the absolute deviation is. Okay. So in this case, we're working with time. And so we're going to set up the equation so that it is x minus whatever the number is supposed to be. How long is this ad supposed to be? 2 minutes. So we're going to write up here x minus 2. How much can it be off? 0.05. That's the absolute deviation. So we're going to put 0.05 over here. This absolute deviation is the amount of, you might say, error that is possible. That could be one way to say it. The amount of error or the amount that something can be off. I guess that's error. Well, you guys have solved problems like this before. We would have what as our 2 equations, please? What would our 2 equations look like for that absolute deviation? Rebecca?
Should I say in the bars? Okay, x minus 2 equals negative, negative 0.05.
Okay.
And then x minus 2 equals 0.05.
Okay. She did the negative first and the positive second. No big deal. It's okay. Makes no difference. Okay. So now solve them both, and we will have x equals and x equals. What is the x equal to on this first equation up here? What is x equal to on this first one, Ben?
1.5.
1.5? No, it is not. Might want to check out your math. Jake?
What does X stand for?
The actual time that it ran. Okay? The actual time. I shouldn't say actual, I should say exact. The exact time it ran. Time of ad. Okay? The exact time minus what it was supposed to run for equals how much it was off. So on this first problem, what do we have up here for an answer? I hope you used your calculator. Okay, Ellie?
1.95.
1.95. See that? A 1.95 what?
It's minutes.
Minutes. Okay. How about the other problem? The other margin of error. Go ahead, Jordan.
2.05.
2.05. And what are we going to put behind it? Minutes. Okay. So the ad could have been 1.95 minutes up to 2.05 minutes. That could be the length span, you might say, the minimum and the maximum for the length of the ad. Okay. So this X up here is exactly how long it was, whatever that was, minus what it's supposed to be, can be no more than this absolute deviation here. Okay, 0.05 is how much it can be off. Let's try another one. Hopefully this will help out with you. Before the start of professional basketball, a basketball must be inflated to air pressure of 8 pounds per square inch, 8 psi. An absolute air of 0.5 PSI. It says find the minimum and the maximum acceptable air pressure for the basketball. Okay, I'm going to pause for a moment, and why don't you just talk to your neighbor real quick and come up with what your equation is. Jordan has written up here the absolute value of x minus 8 equals 0.5. That is correct. Whatever the basketball pressure is, minus what it's supposed to be, 8, when we take the absolute value of that, it has to be at least 0.5, or it can be no more than 0.5, we'll put it that way. So we want to find the min and the max for this. Can you give me the two equations that we're going to use from what Jordan gave us up here? Give me the two equations that need to be used from what Jordan gave me.
X minus 8 equals 0.5. And x minus 8 equals negative 0.5.
That's right. What's this first answer going to be, ladies and gentlemen? 8.5. And let's make that PSI, pounds per square inch. What's the other answer going to be? 7.5 PSI. So the maximum air pressure that can be in the basketball is 8.5 PSI. The minimum is 7.5 PSI. What happens if it's more than 8.5 PSI? It might pop. That's right, explode in your face. That would not be a good thing. What else? If it doesn't explode, what else could happen if it's too great a pressure in there? Anybody ever work with a basketball that has too much air in it? It'll bounce too high, that's right. How about if there's not enough air in it? It's less than that 7.5 PSI. What happens to a basketball that doesn't have enough PSI in it? It doesn't dribble very well. What do we call it? The ball is flat. Yeah, the ball's kind of flat. It goes boom. It doesn't dribble very well. Okay? All righty. Questions? All right. As these guys were talking over here, I just kind of copied what was the original equation. Yeah, x minus whatever that number's supposed to be, put it in absolute value bars, equals the absolute deviation.